Okay, so I've said, remember, labeling each vertex, so labeling each of the corners really helps because it enables you to redraw your triangles that you're interested in. Now,
sorry, Miss Harrison.
yes,
For
Danny.
the first page, should we be working them out? I had to go get this off the printer. Did you do them?
We did that last lesson, sweetheart.
Okay.
Okay. Excuse me. So when they're going through the box, even though they don't look it, they're going to be a right angle triangle. Okay, do we remember we talked about this? Oh, jeepers creepers. Technology is a dream. Okay, so, oh my goodness. Where's Julia taking us for a little walk?
I just have to print this out.
All right, oh my gosh. I don't know if it's my internet or what. Oh, I'm stopping presenting. Haley, what are you doing? Okay, so, oh my gosh. What? I forgot to start recording again. Oh, darn it. And so theta is...
Is that a 4? 25.2.
Oh, thanks. So that's an 8 over 17. Sorry, my computer is being really slow today. Okay, so Elsa, that was the opposite over adjacent measurements, yeah? Okay, do we understand that? So the actual maths of it is nothing different and actually in some ways easier than the work that we've been doing with the sine and cosine rule, because it's just going back to SOHCAHTOA. But in order to establish your measurements, you have to think that little bit further and you're going to have to do that extra work. So we had to use this triangle here in order to have enough information for this triangle up here. Okay? So I'm going to do another example. Julia, are you still around, Ellen? Or did you leave forever?
I'm here.
Okay. Do you mind turning your camera on? Everyone else has got them on. Thanks. All right, so, thanks. Okay, here we go, another rectangular box. And we need to find length EG. Okay, so we're looking at our diagram. We're looking where EG is. And so, Erin, can you tell me a triangle that's going to help me establish the length of EG? I want to make that into a triangle, a right angle triangle if possible.
EH and then HG.
Nice. Okay, everyone happy with that? Oh wow. Ava Rossa, which other letter could I have used if I hadn't used H? Can you see? Yeah, that's you, Ava Rossa.
Sorry, I didn't know if I'm on mute. C?
No, not for length EG.
F?
Yes. Okay, so we used H, but we could have used F because it's the other side of it. Okay, the reason I said no to C is because we don't have enough information to be able to use that to help us. Because we need to find this length, we've got this one and this one already. Okay, so length HG I can now label on my diagram as 10. I know that this is a right angle, and EH would be the same as FG. Okay, so that would be 3. All right, so are we going to use trig or Pythagoras for this, Elsa?
Pythagoras.
Yeah. So it's the hypotenuse, so we're squaring and adding. That's the square root signed by the same. So that's 10 squared. Plus 3 squared. That's really not
I
clear.
got 10.44.
Thanks.
Same.
See, going ahead me now, Danny. I don't know who else said same, but awesome job. Okay, these ones we want to make sure that we've got quite a few digits because we may be using them again later. But if we look at the question, it's asked to round to 3 significant figures. So how would I round this one? Erin?
It would just be 4.
10.4.
It would be 10.4, sorry.
Yeah.
40.
No. All ixnay. No, there's no 0.
Okay.
Okay? All right, B. This is very painful.
Can you not use your touch screen thing?
No, for some reason it doesn't work when I'm presenting.
Miss Harrison, is it recording right now?
It is, but there was a massive chunk that wasn't.
Oh,
So I'm really sorry.
it's okay.
After I had a glitch, I forgot to turn it back on. Right, so now we're trying to find length CE. So I'll choose a different color. So we now want CE. So we need to draw a new triangle that CE is involved. Okay, so Haley, which 3 letters might we use for our triangle? Remember, we're trying to have a right-angled triangle.
You can use CEG.
Nice. Oh God, this is just so annoying. You lot should be way ahead of me doing this. Okay, so that's my G. They all look exactly the same letter. This one's C. Okay, we now know EG, we just worked that out. Okay, so that one's 10.4, but let's put 10.44. To be a little bit more accurate. CG, we know is 5. That's from the diagram. Okay, so that one's from here. And we're trying to find CE. So again, we're using Pythagoras. Girls, I can't write it out. It's just too painful.
It's 11.5.
Thanks. Okay, so we're doing 10.44 squared plus 5 squared square rooting. Yes? Sorry, what did you say?
11.5.
Thanks. Oh. Okay, the angle CE makes with the plane, excuse me, EFGH. Okay, now they've helped you out by telling you it's angle CEG. You just need to be able to do this on your own sometimes. So when they talk about a plane, They don't mean something up in the air, okay? They're talking about a flat surface, okay? So, or a face of the solid. So the plane is this thing on the bottom. So the angle that this line, the CE, makes with this plane is this angle here, which is this angle here. Okay, so the CE makes this angle with this plane. Okay, so the plane is the solid, the whole face, but we only need to look at this line. Okay, that's the hardest thing, I think, just being able to do that. So we've actually got all three measurements. We worked out one of them, well, we worked out two of them, sorry. So to be honest, it doesn't matter which one you use here. You could use SO, car, or TOA, because we have opposite, adjacent, and hypotenuse. I would suggest avoiding car, because we worked out both the adjacent and the hypotenuse. At least with SO or TOA, you've got one of the lengths that they gave us. Okay. This is hurting it's too painful for me to write this, but obviously you would write, so if we use sine, we would say sine of the angle is 5 over 11.5, and then inverse sine to find the angle. So did anyone have that? Has anyone done that ahead?
I got 25.3.
Thanks. So 25.3 is the answer. Oh, see, you can't even read that. Oh my God.
So it would be 5 over 11.5.
Yeah, if we use sine, yeah. And if we used TOA, it would be 5 over 10.44. But you should get the same answer no matter which way around you do it.
You would do sine like theta equals 5 over 11.5, and then would you do like the sine minus 1?
Yes. Yeah, exactly right. Yeah. Because whenever you're finding angles, you're always going to be using the inverse button. Okay?
So you would. Okay. So what was the answer?
I can't remember. What was it? 25 point something?
25.8.
25.8? Honestly, I'm trying to type now and that doesn't even come up. Oh, it's just painful. Okay, I don't want to play this anymore because it's doing my head in. So I'm going to set you off just for the last 17 minutes. You can have a go at some of the questions. So there's an exercise from a textbook there. It's got some sine, cosine, and everything. So there's practice of all of those types. But at the end of, see, I've started working now. At the end of that chapter, there is some 3D stuff. Okay. I'd show you it, but again, it's going to take 20 minutes to actually show you it. So on that same, in the Google Classroom where this notes was, there will be an exercise for you to have a go at. Then there's the answers to the whole textbook actually, so you'll need to scroll through to find the answers to that particular exercise. Okay, so have a go at some of those 3D problems. I'm aware that I haven't done the other example, but to be honest, it's just too painstaking to have a go at. Have a look at it perhaps, and we can make sure that you're comfortable with it next time I see you. Okay, good. All right.
Thank you.
See you later, ladies.
Thank you.